Hi guys, this is going to be your review video for the test 12 test over area. Alright, let's get after this. Find the area. The figure is not drawn to scale. So here we have a parallelogram. Remember a parallelogram? You just have two pairs. So you have one pair here, and then you have another on the sides. Two pairs of parallel lines, that is a parallelogram. And just like if this were a rectangle, your area is just going to be base times height, because after all, a rectangle is a parallelogram. So my area is just going to be base times height, base times height, base times height. So just looking at this here, so here 36, this is my base right here. This is my altitude, this is my height. Remember, your altitude extends from a corner down to your base. This is your height. This is a side measure and has nothing to do with anything. You're just looking at the base and the height. So looking at this here, all I'm going to do is multiply 36 times 33. So I'm just going to say 36 inches times 33 inches. And if you put this into a calculator, you're going to wind up with 1,188. And inches times inches is inches squared. That is your area. Okay. So, you got that there. Number 2. We're doing the same thing, but this is a triangle. The area of a triangle, your formula is area equals 1/2 base times the height. Okay, this almost looks like the area of a parallelogram, which is base times height, but it's half of that, because think about it. It's like having a rectangle and then you cut it in half. So get it? That's why it's just half that area. Okay, so when I do this, again, all I'm looking at is my base and my height. So I'm just going to say 1/2 times the base. Well, my base here is going to be 10 yards. And my height, remember, extending from a corner down to your base, is just going to be 3 yards. So 1/2 times 10 is 5, times 3 is 15, and this is going to be 15 yards. Yards times yards is yards squared, which is square yards. Okay, and that is it. Okay, number 3. So here we have a composite figure. Composite meaning there's more than one put into this. Here we have a rectangle, and then here we have a triangle. We're trying to find the area of all of this. So we're going to just do this in parts. We're going to find the area of this parallelogram, or this rectangle, which is just going to be base times the height. So you're just going to have 9 times 8. And then you're going to have the area of this rectangle, this triangle, which is going to be the base, which is 11 times the height. Well, what is this? Well, first of all, this whole thing is 13 on this rectangle, and this portion right here is 8, which means that this right here is just 5. So this is 5, and then this is 11. So let's put this all together. So that means that I'm going to have the area of the rectangle plus the area of the triangle, which means I'm going to have 9 centimeters times 8 centimeters. I'm sorry, not 8 centimeters. This whole thing is 13 centimeters. And then the area of the triangle, I'm talking about 11. First of all, it's 1/2 times 11, the base, centimeters. And then times the height. Remember, the height here is just 5. I know that because this is whole thing is 13 on that rectangle. This portion here is 8, and so this has to be 5 right there. So the area of this, the height here is just going to be 5 centimeters. So when I multiply this all together, 9 times 13 plus 1/2 times, you can put this to a calculator, plus 1/2 times 11 times 5. This is going to, well, this will end up being, this will be 117 plus, you put this to a calculator, you're going to get 27.5. and adding that together, we're just going to get a total area 144.5, and this is going to be centimeters squared. Remember, area is always square units. Okay, number 4. Find the area of a parallelogram. The area of a parallelogram is 280 centimeters squared, and the height is 35 centimeters. Find the corresponding base. Okay, so remember, same formula as you're just finding the area of a parallelogram. So you're saying A equals B times H. Well, here they gave you your area. Your area is 280 centimeters squared. I don't know what my base is. That's what I want. And here I have a height of 35 centimeters. So here I just want to solve this for the base. So let's just divide this. That's terrible. Let's just divide this by 35 on both sides. 35 centimeters, 35 centimeters. So this cancels right there on the right side. 280 divided by 35. First of all, this centimeter is going to cancel one of these. So my answer will still be in centimeters. And this will be my base. Base is going to be 280 divided by 35 is going to be 8. And this is going to be in centimeters. Okay, so number 5. An isosceles triangle has an area of 125 square feet. If a base is 16 feet, what is the length of each leg? Round the answer to the nearest tenth. Okay, so think about what we have here. First of all, we have an isosceles triangle. Okay, so let's just draw a picture here. So it'd be like something like so. We have a base here of 16, so this whole thing is 16 feet. Okay, but this is isosceles, so let's just kind of cut this in half. Well, if we cut this in half, that means that now I have 8 and 8. Okay, and here I have ultimately what I'm looking at is I'm looking for the length of these legs, because these are going to be the same. Let's just call those x. Okay. Okay. Oh, and the area is 125 square feet. Okay, so remember, the area of a triangle, you're talking about 1/2 the base times the height. Is going to be equal to 125. And I need to determine the height. So here I know I have 1/2. My base is 16. My base is 16 feet. I don't know what the height is. This can equal 125. So let's say I go about solving for my h. 1/2, half of 16 is 8. So if I divide both sides by 8, this will give me my h. 125 divided by 8 is going to be 15.625. Okay, this is not my answer, but I need this because, remember, I'm trying to determine what this x is. Okay, so basically what I'm going to do, since these are basically twin triangles right there, I just need to solve one of those for the hypotenuse. Okay, so I'm going to have to use the Pythagorean theorem. That's like just taking one of these right here. So I know that my height here is h, which it ends up being the 15.625. I'm going to use this base of just 8 because it's just for one of these triangles, and I'm trying to determine what that length is for the hypotenuse. Okay, so I'm saying that I have, let's make a triangle over here. Remember, this is 15.625. This is 8. I just want to know what this hypotenuse is. I'm just going to call it x. I could have called it c. I could have called it whatever I wanted. Okay, so let's just solve for that right there. I'm going to have to use the Pythagorean theorem. So I know I'm going to have x squared equal to 8 squared plus 15.625 squared. And if I have that, and if I put this into a calculator, I'm going to wind up with x squared equals 17 point, well, after I get the square root, this will be the square root of, this will be 17.5539. Okay, so the square root of that both sides, so I'm going to get x equals, square root of that is just going to end up being actually, I'm getting right to my answer. So this is going to end up just being, if I square about both sides, I'm just going to have 17.5 or 17.6, because we're rounding this to the nearest tenth. Okay, so just one decimal place. So 17.6 feet. Okay, so anyway, so let's look at number 6. So here we have, we want to find the area of a trapezoid. Well, the area of a trapezoid, you're just saying that the area is going to be 1/2 times the sum of the bases. You have two bases. You have 5, and you have this one down here. Now this is tricking you, okay? You can't look at this and say, okay, this is 5, so this is 5, and this is 2. And just assume that because this is 2, that this one's going to be 2. It's not. They're trying to trick you. Remember, this is a 45, 45, 90 triangle. And a 45, 45, 90 triangle, your legs are the same. Well, these are your legs, so this is 9. Okay, they're trying to trick you right there. If you said that that was 2, and then this is 5 and that's 2, that is incorrect. This has to be 9. If I really wanted to, I could find this length here, because this would have to be 9 times the square root of 2, but this is not important here. Okay, I needed to find this over here because I need to find what this entire base was. This is base 1, is 5. This whole base right here is going to be 9 plus 5 plus 2, which is going to be 16. So in our formula, I'm going to have 5 plus 16, and then times my height. My height here is 9. Okay, this is my height. That's 9. So I'm just going to have 1/2 times 21 times 9. And if I put and multiply all that together, I'm going to wind up with 94.5 centimeters squared. Okay. So like I said, so that was the big thing on this one. They're trying to trick you. Okay. Because you're probably going to look at this and say, okay, that's 2, so that one has to be 2. It's not. This is a 45, 45, 90 triangle where both of your legs are the exact same. Well, this one is 9, so this one has to be 9. I know that this will be 9 square root of 2, but that's not important. Okay? I just needed to know this because this means my entire base here is 16. 9, 5, and 2 is 16. Okay. That was number 6. Okay, number 7. So we're trying to find the area of this kite. When it comes to a kite and a rhombus, the very simple formula, you're just saying the area is going to be equal to 1/2 times diagonal 1 times diagonal 2. So when I look at this here, this is my whole diagonal here. This vertical one, I'm saying 6 and 12. So let's say D1 is going to be 6 and 12. 6 and 12 is 18 feet. And then diagonal 2, this is going to be 2 and 2. So let's say that D2 is just going to be 4 feet. And if you had called this D1 and this one D2, it really doesn't matter. Okay, so let's now multiply these together. So I'm going to say 1/2 times 18 feet times 4 feet. Okay, half of 18 is 9. 9 times 4 is 36. Feet times feet is square feet. And that is that. Okay. Okay, let's look at number 8. Just like number 7, your formula is going to be the same for a rhombus and a kite. They have the same formula, which is a half times d1 times d2. You're just multiplying the diagonals. The difference being, you see how here with a kite, you can separate these diagonals, and you have to add those together. See, 2 and 2 is 4, and here is 6 and 12 is 18. When you're talking about a rhombus, they're not going to do that. Okay, so I'm just going to say my area is going to be 1/2 times d1 times d2. So here we're going to say d1 is going to be 9 and 9, which is 18 meters. And d2 is also going to be 18 meters. Okay, 9, 9, 18. Okay, so I'm just going to say that this is going to be 1/2 times 18 times 18. And when I multiply all that together, I'm just going to wind up with 162. And this will be meters squared. Okay, I meant to put meters, 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 meters makes the meters squared. Okay. Okay, number 9. The widths of two similar rectangles are 21 feet and 18 feet. What is the ratio of the perimeters and then of the areas as well? So remember, all we got to do is find the scale factor. Okay, and we already have one is 21 and one is 18, so that can be a scale factor right there. You might also have it called similarity ratio or something like that, but the same thing is just your scale factor. So we're just saying that this is going to be 21 to 18. Okay, we can reduce this. 21 and 18 both have 3's in common. That's like saying 3 times 7. And 18 is like saying 3 times 6. Cancel out those 3's. It's just going to be 7/6. So remember, when you're talking about the ratios when it comes to the perimeters. So for perimeter, this essentially is like our scale factor right here, and it's the exact same same thing is going to be for the perimeter. Okay, and for the area, it's still going to be 7/6, but it's going to be squared. So this one's going to be 7/6 squared. And if I square that, 7/6 times 7/6, 7 squared is 49, 6 squared is 36, and that's that. Okay, so for the perimeters, it's just 7/6, which is the same thing as your scale factor. And the one for the area is the same thing, except that it's squared. Okay. All right. So number 10, find the ratio of the perimeter of the larger rectangle to the perimeter of the smaller rectangle. Okay, so this one I'm specifically doing larger to smaller, which is fine. Larger to smaller. If they don't tell you which way to go as far as like smaller to larger or larger to smaller, whatever it is, if they tell you that, do it in that order. If not, you can just do them in that order. Just like up here where I just did 21 to 18. Okay, so anyway, so when I'm doing this here, the larger one is this big one all the way around here, right? And we're looking for a perimeter. Well, I can just add these up, because if this is 12, that means I have another 12. And if this is 4, then I have another 4. Or I could just add these together and multiply by 2 is the same thing. 4 plus 12 is 16. 16 times 2 is 32. So I'm just going to say that the ratio, you're just talking about 32, and this is feet. So feet squared. No, just feet, not squared. Just feet. And then the smaller one, this is 3. So it would be like saying 3 and 3, and then 9 and 9. 3 and 9 is 12. 12 times 2 is 24. So this would be over 24. Remember, this is not squared. Okay. So the feet is kind of irrelevant. It's just 32/24. And 32/24, these both have 8's in common. This would be like saying 4 times 8. This will be like saying 3 times 8. The 8s will cancel each other. This will just be 4 over 3. Okay, and that's all I need here. Okay, and there we are. Just 4 over 3. That's it. Okay, remember, if it's perimeter, that's exactly what it's going to be. Had it been area, then I would have to square that. Okay, so I have that there. Number 11. The trapezoids are similar. The area of the smaller trapezoid, remember area, they just said area, is 709 square meters. Find the area of the larger trapezoid to the nearest whole number. Okay, so what does that mean by this? So first of all, they're giving us these, we can do scale factors on this. Okay, so on this, I'm going to set this up. I'm going to say like the smaller to the larger, since they just did the smaller first. They did the smaller. So I'm going to say the smaller to the larger. So first of all, I'm going to say 27 is to 39. 27 is to 39. Okay, so there's for those ratios, but I have to do it with the area. Well, they told you that the area of the smaller trapezoid is 109, 709. So I'm going to say that this is 709. And all I'm doing is looking for, and this was meters squared. And I want this area. This is what I'm looking for here. So I'll just say A, because I'm looking for area. So just like y'all did when y'all were in 7th grade, you're just going to cross multiply. Okay, so I'm going to say 27 times A. 27A is going to be equal to, and then you're going to say 39 times 709. And if you multiply 709 times 39, you're going to wind up with, oh, hold on, one thing I forgot. Remember, this is, these have to be squared because you're talking about area here. So this has to be squared. Yeah. Anyway, so it's still the 27 and the 39 and all that. But you're going to have to square this. So squared and squared. Anyway, so when you do that, this is going to be 27 squared. So 27 squared. It'd probably be easier if I just didn't do this first. Let me see. I could say 27 squared times the A. If I had to do it over again, I wouldn't have said that. I would have just said the 27 squared, which is going to be 729. So let's just get out. Let's not do that. So I'm going to say 729. 729 is 27 squared. And 39 squared is going to be 1521. Okay. And this is going to be equal to, now this is going to be the areas. You know, the 709. And then over A. Now this I'm going to cross multiply. So 729 times A. So let's say 729A. And now this is going to be a big number. 1521 times 709. You definitely want to do it in the calculator. That's going to give you 1,078,389. Okay. And then I just want this A. So let's divide both sides by 729. 729. Okay, so that cancels there. So running out of room here. So if I divide this, I'm going to get 1479. So let's say that this is going to be 1,479. And here I am rounding this to the nearest whole number. So that's for that. That's why this does not come out exactly like that. But this is rounded to the nearest whole number, and this was square meters. Okay. So again, we're saying smaller to larger. We're saying 27 to 39. but since we're talking about area, we have to square these, and then we're going to cross multiply. I just rewrote this over here. 27 squared is 729. 39 squared is 1521. Cross multiply there, and solving for, so we get 729a. 1521 times 709 is this big number, 1,079,389 divided by 729, and this will give you the nearest whole number will be 1,479, and this will be square meters. Okay, so let's look at number 12. A rectangular napkin costs $3.25. A similar tablecloth is 5 times longer and 5 times wider. Okay, how much would you expect to pay for the tablecloth? Okay, it would be it would be incorrect if you were to say, okay, well then it's just going to be 5 times, and then you'll just multiply 5 times 325, but that's not correct, because for whatever this tablecloth is, that would be like saying that was your base and your length and your width, or however you want to say that, right? So the area of the napkin would just be length times width, right? Well, if you multiply, and for that, this is going to end up being $3.25 per, right? But if you multiply it's going to be 5 times longer and 5 times wider. That means that your overall area, you're talking about 5L times 5W, in parentheses 5W. Well, this comes out to be 25 times L times W, right? Well, L times W, that was $3.25, right? So this is not going to be 5 times, since you're multiplying, increasing each of these by 5. You're not going to say 5 times this. It's actually going to be 25 times that. So this is just going to be 25 times $3.25. And if you multiply that together, you're going to wind up with $81.25. Okay, for that larger tablecloth. Okay. So yeah, that's the key thing there. It's not going to be 5. It's going to be 5 times 5, which is 25 times that. Okay, which gets you that 81.25. Okay, and number 13, last one. 2 trapezoids have an area of 432 and 48 square centimeters. Find the ratio of similarity. Okay, this is not asking you about, just to find this between these. Remember, these are areas, and areas are squared, okay, or were squared. So when I'm going to do this, I'm going to say 432, and yeah, I'm going to divide it by 48. Okay, well, if you divide these, you're going to end up getting 9. Okay, but remember, this was squared. Okay, so the way you're going to say this is, remember, we have to get the square root of these. Okay, well, 432, is like saying the square root of 48 times 9. And then, of course, divided by the square root of 48. So I'm saying the square root of 48, let's just separate these, square root of 9, and the square root of 48, I could say times 1, right? Well, these cancel each other. Square root of 49 is 3, square root of 1 is just 1. This is your ratio of similarity. Right here, this is 3 to 1. Okay, or you're going to get done the other way. It would be 1 to 3, whatever. But 3 to 1 is probably the way you're going to want to say this. Write your ratio with the colon, so you're going to say this is 3 to 1. So if you do it with the fraction bar, that's fine. It's the same thing. So this is probably going to be multiple choice, so whichever of those that they gave you, take it. Okay? Anyway, so that's that. You have any more questions? You have any questions on this, please watch this over and over again. And if you have any questions, make sure you message me in Canvas or email. And good luck on your tests. Talk to you later.